have right here. Things that we want to talk about though is identifying what is clean and what's dirty. How do we make clean code? How do we keep clean code? And how do we clean up code after somebody else? The reason this became a topic for me is that there's a lot of signs that you've seen in kitchenettes and things like that talk about attention. You know, your mother doesn't work here. Please clean up your own mess. Well, I consulted into a place once that as you did your source check-in, that was the message that flashed across. Clean up your own mess. And it made me think that what do we do as developers and how do we do it and how do we keep it clean? How do we make it so that other developers really can follow behind us? This is especially important for me and probably, how many of you out here are full-time employees and work on the same project pretty regularly? So that means the rest of you are pretty much consultants that come in and do more short-time gigs. Well, when you come into those kinds of projects, the first thing that you'll see is you spend, X amount of time sitting there trying to figure out exactly what's going on. And invariably, if you don't make the right selection, you'll look at the worst piece of code in the application. You'll look at that, you'll figure that's what your baseline is, and then you'll try to go from there. Imagine what it would be if you come into a code base that was perfectly clean, made sense, was well commented, there was external documentation for it, things like that. Imagine how easy your job would be.
It's a fiction.
Well, see, that was going to be my next question. How many people have ever seen that kind of a code base?
I saw a unicorn.
Second advice. But think how more efficient we would be, how much more we'd get done, where we would be if we had better code. Normally now I'd like to say something about how I always try to write clean code, but there's too many people out here that have seen my code that I can't really say that anymore. So we'll just go on right past that. Clean code. So the cartoon here gives the best demonstration that I can think of for what is clean code. You get in, you get a group of developers looking at it, and they just sit there and go, dude, what is this? What do you mean by this? So to get clean code in my mind, what I'd like to do is get a discussion from you a little bit later, but in clean code, you should be able to easily understand the structure of the code as you look at it. You should be able to easily understand the logic that's going on within that structure. And then, in my mind, some of the most important things are the reasons for the decisions are well documented. This doesn't mean just code comments, things like that, but you really need to know why the developers took this decision. Why was this algorithm chosen over this one? Because what you'll end up finding is they may have started off with the first one, went to the second one because the first one didn't work. You look at it without that background, you may switch it right back to the first one. So that kind of information is, in my mind, imperative to be part of the code base to keep it clean and to keep it active and useful. So we've talked a little bit about it, but why would you have clean code? If you look at it from a business perspective, the ability to respond to change requests stays constant. So let's talk about that. When you get into deeper code and your code gets, for lack of a better term, nastier, each new fix, each new implementation, each new thing that you have to add into it takes a little bit longer. However, the cleaner your code is, the better organized it is, the more maintainable it is, the time for requests stays pretty constant. So if you look at it from a project manager point of view, you'll actually be able to predict what kind of output you'll get. As your code gets dirtier, as it gets deeper and deeper, closer to the release date, you find that each new piece of functionality that you add in takes just a little bit longer. The cleaner the code is, the easier it is to bring a new resource in. As most of us are consultants or contractors, the easier we can get in, the faster we can learn what's going on, the more productive we can be right away, the more value we can bring to the customer, the higher rate we can charge, everything like that. So it's in our best interest to make the code as clean as possible for the next one that comes through. Another one that's a big word and a big topic now is unit test coverage. The cleaner the code, the easier it is to really have valid unit test coverage. You can run a unit test statistics and say, hey, look, I see 80% coverage. But for dirty code that's poorly written, poorly maintained, and doesn't have all the available paths that you would think, that coverage number doesn't mean as much as you would expect. Lastly, and obviously for all of us that are have to fix any defects, finding the defect, fixing it is much more efficient, much quicker. You can go through those a lot easier and you can make a better solution out of it. So, in my mind, that's why clean code is really important and why we should all probably try to strive to get more of it. When you look at code, there are some indications of bad code. Opacity and obscurity. That's where a lot of time is spent trying to understand what is happening in the code. I mean, we've all sat there, we've walked through a method 5 times. It's 100 lines long, and by the end of it, at the end of the half hour that you just spent on it, you still have no idea what's really going on there. There's whole classes that could be like that. So if you see those kinds of things, the more time that you spend in it, or the more confused you are about what's really going on, that's a good indication of a bad structure. Needless complexity. Sometimes you'll get places that will just stack base classes on top of each other. So as you sit there and you trace through it, you may be working in an object that has properties 8 classes down. With no documentation on it, finding those can get pretty troublesome. So sometimes you have to sit there and look at it. Is it too complex? Is it what we need? That's always something that you should keep in mind. Is there any way that we can keep this simpler? Because in a lot of ways, simpler means cleaner code. Another indication that you'll see is what we call magic numbers, fairy pixel dust numbers, things like that, or configuration items that never change. Do they need to be there? Do they represent anything that actually has value in the application? If they never change, do they actually need to be a configuration item? Things like that, just other things to look at. Last thing is when you find common features that are built into the high-level project. So logging, data access, things like that. If you have your own logger class in every one of your projects in a 15-project solution, is that the best way to be doing it? Does that mean that you're actually implementing logging differently for each one of those projects? Is it just code that's really throwaway because you've duplicated it? I mean, that kind of an approach is something that you could see as really an indication of a bad structure. Is there any questions about structure and what I mean by bad structure on that? Before we look, yeah.
Clarify that last word.
Okay, so let's say that, think about it, you've got an application that's a web store. You've got a order module, you've got a user module, you've got a fulfillment module for the people doing the work, an email management module, things like that. If they each have all of their own logging code in each one of those projects, is that necessarily the best solution? Would it be better to have a common project that would have that in it, that then they would all share? It could be duplication of code. Or it could be completely independent interpretations of the same need. Any other questions on structure? So we talked about bad structure, good structure. These are like, if you look at your old books and things like that, most of these won't be a surprise for you. Loosely coupled projects. The more loosely coupled your projects are, probably the better the structure. Dependencies between projects are obvious. Names and namespaces are useful and descriptive. If you see thing in the title, it's probably not as useful and descriptive as it could be. It's one of my favorite things to use. Consistency. The same thing is done the same way everywhere. It's always useful to see that because it makes it easier to understand code that you haven't been into. There's a lot of use of abstractions rather than concretions. The more you can stay away from the concrete examples, the the cleaner your code is likely to be. Lastly, it's a